Hello everyone, I'm John Welty and welcome to Shop Talk with Mestek Machinery. In today's podcast, I'm joined by Mike Bailey and David Daw, two gentlemen with over a combined 80 years in the industry, icons of the industry, you might say. And our discussion focuses on the software that's used in today's HVAC duct and fittings fabrication, and in particular, the data exchange for BIM modeling and how it's evolved to become the standard of today. Thanks again for joining us. Welcome to Shop Talk with Mestek Machinery. I'm John Welty. I'm here with David Daw and Mike Bailey, two icons of the industry. And we're going to be talking about software in general today and a little bit of the history of how some of this equipment has and the whole business has come together. And so let's kick that off to David. What have you seen being changing with that and how businesses are being run differently today than they were, 40 years ago?
Well, when I first started out, everything was manual. In the beginnings of the software was on the CAM side, computer-aided manufacturing. And that was started with very rudimentary labeling programs, which were developed by Mechanical Data, East Coast Sheet Metal, CTI, very early 80s. And these were programs that had somewhat of a smart label, data attached to them, where it had the cut size, the gauge of metal, and all a contractor had to do then, or a worker was manually scribe onto the sheet metal and then physically cut it with a shear or a snip. And that development led to the machinery slash computers machinery side, where the labels then ended up being written with code, which ended up driving a plasma cut or ultimately a laser. But that was actually the beginning, from my knowledge. And then from that, maybe the mid to late 80s, the development of CAD, computer-aided design, of computer-aided drafting, which now allowed you the ability to instead of manually drafting a floor or a air handling unit system, then you would go to a computer, and that could get done so much faster. But that also had data attached to it too, which ultimately led to the ability to download from a CAD drawing to a machine to both cut the fittings and to drive the straight sheet metal on a coil line, basically.
All right.
There was also estimating. Estimating was done all manual back in the late 70s, early 80s, and a couple of companies by the name of Estimation for one and QuickPen started developing takeoff mechanisms with the roll wheels or a QuickPen that could do point, and ended up creating a estimate that had, again, smart data attached to it as far as how many pieces, the gauges of metal, material, labor cost. So you could actually end up with a computerized estimate, which was infinitely more accurate and fast than doing it manually. And those were the two big things that happened during the 80s.
Interesting. So that essentially they were using the software in the back office in order to first put some smarter tools in front of the people that were producing the products. Correct. And then it actually extended out into the shop to actually produce the products itself.
Correct.
It's a fascinating change. Mike, can you speak to that?
Yeah, I don't have 40 years of history like David does, but so when I came into the business in 95, the computer-aided drawing was here, CAM was here, but it wasn't without problem. Yeah, it was with a lot of problems, actually. You're only as good as your drawing, right? And that comes from architects and engineers. So when the computer-aided drawing and shop detail drawings, when they started to come out, it sped up the process, because in construction today, I think we talked about it before, these guys get a job on Friday, they want you on site on Monday. So you've got to be able to draw, and today they use more of a Revit-based program than an MEP-based program, so all the trades can actually draw at the same time. And what that's about is collision checking to make sure you don't have a lot of collision between the trades on the job. So it's less input, greater output, less chance of human error, that's for sure, like everything else we talk about. But the ability to do your shop detail drawings based on your specs and scopes of your shop and the hardware you have, to download to that cam station, which then can download to the water jet, the plasma, the laser, and the coil line. It's just created a seamless operation when it comes to getting that intelligence to the shop to manufacture and to lessen any human error, right? So more and more you see the contractor base going toward that technology. If you have not, you should at least be curious and want to know more about it and reach out. But it's here. The drawings are better today. We do recognize that. Architects and engineers, I believe, heavily rely on the contractors to do this. So it's helped in that process as well.
It's good. And for those listening or watching, we're going to have some links available. The Revit software that Mike Bailey was speaking about is an Autodesk product, and we can give some links to that. But there's a wide variety of tools out there that are being used that you see in place. But we find that a lot of the industry does seem to be revolving around those things. So we talked about this a little bit in a previous episode when we're talking about the shop floor layout and just kind of that whole flow. So this software that we're talking about is helping to facilitate that exchange of information that starts in the architectural stage. Is that right? And and that it has to be engineered, and that knowledge that's being captured by engineering has to be passed down through. There's a lot of opportunities for making mistakes if the data is being handed off and transcribed from system to system. And so that's what you're seeing, is that there's a seamlessness in order to try to avoid those human errors where the information's being changed from here to there, because they can actually pass it all through as a solid stream of information all the way down to the machine. Is that what you're saying?
Yeah, I think you look at the Trimble Siskiyou product. That's a Revit-based product. It's a level detail 400 product. So the detail in that program is very detailed, if you want to put it that way. Also, it has intuitive products in it. Millions of products have been spec'd from manufacturers all over the country with their specifications and pricing within that
And built right into that.
Built right into it. So you can actually click on that louver, and if it's a green heck louver or a fan, it'll give you the spec and the price.
Wow.
So there's over millions of items in that Siskiyou Revit-based platform to help with that process as well. So it goes right on down into purchasing, goes into procurement based on the building. So it just it gets these guys out ahead of any problems going forward.
Well, it's got to be a tremendous time saver for the engineering group then too.
Sure.
Yeah.
Sure.
Interesting.
Yeah, and then and for us, it's we work with a lot of people, but for our machines, we make sure that Welty Automation is up to par with whatever's going on out there with the CAD space or the Siskiyou Revit space, to make sure our machines have the ability to accept these downloads, because today labor shortage is real. It's not getting any better.
Yeah.
So in order to cut down on labor, that's a great way to do it, right? And you have back checks and processes to make sure it does deliver to the machines correctly.
Yeah, and I know we've been involved with a lot of recent changes. It seems to be something that the more we improve upon it, the more we find opportunities to improve upon it further. So
Sure.
It's something that we've definitely worked on quite a bit, especially once some of the benefits of these BIM-based systems is that you now get where the contractors are wanting to cut the takeouts right into the duct as it's being produced in a duct line, which created a requirement for a new protocol in order to exchange even more information down to the machine. Mm-hmm. So I've been involved with some of that and working out those defining what that protocol is, and then learning what things are missing in order to help people understand what it is, how that information does have to digitally be transcribed from the way they look at it. Because it's interesting, to a contractor, they're looking at these products as a finished product, but to a machine producer, we start with a coil of steel. So they look at a piece of duct as where the sticker goes is on the outside. The bends go down, and now you have a rectangular piece of duct. When you make that, we actually bend it up so it's upside down. And we'll have some pictures up on the YouTube video. You can watch that. We'll have some links down below so you can see some images of that. But it's a fascinating thing that it's kind of difficult for people to track those transitions. But literally, the part has to be flipped upside down, and we produce it inside out. And so those are all things that you just take for granted. But they provide some interesting technical difficulties and opportunities for computer error also, because these software packages have to be have settings and everything else in order to make sure that they understand each other and are speaking the same language. And that's where we get into these protocols. So it's been a fascinating journey to set some of those things up. But it's interesting to see how far that extends in the system that we're downloading from.
Yeah, and I think we have some future topics to talk about in the podcast, and that's going to be how do we get the younger generation involved in our industry.
Yeah.
And the younger generation just does not know how much software drives our industry, and it is the number one thing. Yep. So as I'm always preaching, you need to know the software. You need to go into the front office and understand what the processes are.
Yep.
Because how are you going to be successful with the hardware if you don't know what the software is doing? So, and we'll talk about that in a later podcast when it comes to younger generation and recruitment of trying to get the younger generation into our industry.
Yeah, and I think we touched on that in a previous podcast also.
We did.
So we'll expand on that further.
That's how important it is.
Yeah.
Well, the reason why this is may seem basic to the industry, particularly the HVAC industry, but the construction industry in general, once you have a building erected, steel and then fireproofing, or a concrete building, you got what they call the core of the building. Now you have to put things inside so you have an environment that people can work in, or what's called the MEP, mechanical, electrical, and plumbing. The reason why this is so difficult is, think about this. When you move water through a building or plumbing, it's a fairly small round pipe. Same thing with electrical conduits. But when you move air through a building, you have to have a significant volume of a medium to move it, square, rectangular ductwork, or round. So the space inside the building is critical. Well, again, how does this matter? Well, because if the electrical conduit or the plumbing and piping is incorrect, when there's a collision with the ductwork, well, it's pretty easy to put an elbow and bend a pipe around it. But it is extremely difficult to take a, say, 30-inch by 40 piece of ductwork and bend it around to fit. So these collisions are critical. Now, if you wanted to eliminate this whole problem, you would have a building designed around the HVAC system first. But that is not going to be an aesthetic building that you want to live in or work in. So this is the reason why this HVAC design and collision work is so critical. The fact that you can take these mistakes out before you put the building in just saves time and a lot of money.
Well, and I guess the thing that comes to mind with that, David, is that you have some of these projects are massive. I remember one of the customers that I was assisting had done the duct work for the new World Trade Center.
Mm-hmm.
I mean, so you think about the volume of duct that was involved in that project.
Yeah.
It's hard for me to wrap my head around.
Yeah.
But some of those things are going to require a lot of different players to do the design work. And that particular company may have done it all under one roof, but a lot of them don't, right? So you have a lot of different groups that are designing these things on separate systems and need to have those things not collide with one another, which is where you get into that BIM model.
Sure.
Is they're able to do that exchange data, and even though they're not on the same system or even working for the same company, they can work on the same project and understand what choices have already been made by other people, and let people know about, we're going to need to go through here, you're going to need to remove your pipe, right?
Sure.
Or vice versa. So,
and that brings up a good point. I was forwarded to be on site with that mechanical contractor called Heritage Mechanical out in New York. And they were redoing the World Trade Center during that process, but they had also had the drawings from the original World Trade Center.
Oh.
Handwritten drawings, right?
Wow.
The same architect engineer redid the new World Trade Center electronically. So it was fascinating to see the drawings handwritten in the 60s to where we were in the 2007-8 time frame, to see them electronically drawn. It really just brought out the whole situation of automation when it came to the BIM model. So pretty neat.
Yeah, and it's I started in drafting myself, let's just say more than 20 years ago. I don't want to date myself, but when we started, we were on drafting boards. So I know what you're talking about. And when you mentioned earlier about the level of detail 400, when you were hand drawing things, you left out details that weren't necessary, because if you ever had to make a change, you didn't want to have to erase it and redraw it. So, and now in the modern systems, you see much deeper detail, because as you zoom out, they just don't show it to you. And if you zoom in, you can just keep getting more and more and more detail all the way into it.
Yeah.
So it's incredible how much more information they can put into these things now also,
I think it's fascinating.
which has got to be helpful to everybody from from producing the parts that go into it to building the building itself. So
Yeah. I've always said it's fascinating what the human mind can dream up, then they got to draw it,
yeah,
then it's got to fit,
yeah,
it's got to work.
it's got to work. It's
And
usually the tough part.
it does. It does. Between all the trades.
Yeah.
There's always going to be some collision, but the opportunity for less collision is greater than it's ever been.
So you can see all of these tools are really just improved communication between those individuals that are having to be involved in bringing such a big project to
It's a good
life.
way to look at it.
Yeah,
Sure.
interesting. Well, I think that's a good place to stop today. On behalf of Mike Bailey and David Daw, I'm John Welty. Thank you again for attending Shop Talk with Mestek Machinery. Join us again next time. So hopefully our discussion of software and BIM modeling was helpful to you. Of course, each shop is unique and has its own operational needs and constraints, but that's why we're here to help you as you make these evaluations on software and how to improve your operation. So please don't hesitate to reach out for a consultation. The best place to do so is through our website at mestekmachinery.com, and there's absolutely no obligation. We'd love to understand what you're looking to do and see how we can help you achieve your objectives. For now, thanks for listening. On behalf of Mike Bailey and David Daw, I'm John Welty. Join us again for the next episode of Shop Talk with Mestek Machinery.